Let's look at some of the parent functions you should be familiar with and some of their characteristics. The first one is the linear function, sometimes called the identity function, and that's f of x equals x, or y equals x. And it's just a line. Its domain is all real numbers. Its range is also all real numbers. The inverse function is the same, so it's f to the negative 1 of x equals x, so the inverse is the same. And if we're considering whether it's an even or odd function, this is an odd function. If we were to rotate it 180 degrees, it would look identical to the original function. Second one I want to look at is the constant function. Now, this is a linear function, but it's a special case. It's a horizontal line. So it has the equation of the form f of x equals some constant number c. So like I said, it's a horizontal line. It still has the domain of all real numbers, but the range is different. Its range is just one value, whatever that constant value c is. So the inverse function, well, the inverse is undefined, and that's because the inverse is a vertical line, which is not a function. For considering whether it's an even or odd function, this is an even function because it has symmetry with respect to the y-axis. Okay, so the next one is the absolute value function, or f of x equals the absolute value of x. And this has a graph that looks like a V. Its domain is all real numbers. Its range is all the values greater than or equal to 0. Its inverse is a linear function, f to negative 1 of x equals x, but only for x is greater than or equal to 0. And if we're considering whether it's even or odd, this is even. It is symmetric with respect to the y-axis. Next, let's look at the quadratic function, sometimes called the squaring function. This is f of x equals x squared. It's a parabola. Its domain is all real numbers. Its range are all the values greater than or equal to 0. Its inverse is a square root function. And if we're considering whether it's an even or odd function, this is an even function because it's symmetric with respect to the y-axis. Next, we have the square root function. So that's f of x equals the square root of x. We have the graph. The domain are all the x values greater than or equal to 0. The range is also all the values greater than or equal to 0. Its inverse is the quadratic function, so f to the negative 1 of x equals x squared. If we're considering whether it's even or odd, this is neither. If we rotated 180 degrees, it definitely does not look like the original function, and this does not have symmetry with respect to the y-axis either. Next, we have the cubic function, or f of x equals x cubed. We can see its graph. The domain is all real numbers. The range is also all real numbers. The inverse function is the cube root function. And if we are considering whether it's even or odd, this is an odd function. If we were to rotate this 180 degrees, it would look identical to the original function. Next, we have the cube root function, or f of x equals the cube root of x. We see its graph. The domain is all real numbers. The range is all real numbers. Its inverse is the cubic function. And if we're considering whether this is an even or odd function, this is odd. Again, if we were to rotate this 180 degrees, it would look identical to the original function. Next, we have the reciprocal function, which is also the parent function for the rational function. So this is f of x equals 1 over x. We can see its graph. It has two branches. This graph has two asymptotes, one at y equals 0, one at x equals 0. So its domain are all the x values except x equals 0. Its range are all the y values except y equals 0. Its inverse is the same as the parent function, so that means it's also 1 over x. For considering whether it's even or odd, it is an odd function. If I were to rotate it 180 degrees, it would look identical to the original function. Next, we have the exponential function. So this could have different bases. So right here I have f of x equals 10 to the x, or f of x equals e to the x. We have the general shape of the graph. All exponential functions have a domain of all real numbers. The range are all the numbers for the parent function, or all the y values greater than 0. The inverse function, it's going to depend upon what the base was. So for example, f to the negative 1 of x equals log x, meaning log base 10 of x, or f to the negative 1 of x equals the natural log of x, meaning log base e of x. So it would depend upon what our base was. If we're considering whether this is even or odd, this is neither. It has no symmetry with respect to the y-axis. It has no symmetry with respect to the origin. Next, we have the logarithmic function. So we can have different bases here as well. F of x equals log of x, which is base 10. F of x equals the natural log of x, which is base e. We could have different bases as long as the base is positive. The domain are all the x values greater than 0. The range is all real numbers. The inverse function is going to depend upon the base. So we could have f to the negative 1 of x equals 10 to the x if the base were 10. Or f to the negative 1 of x equals e to the x if this were the natural log and the base were e. Even or odd, this is again neither. It's not symmetric with respect to the y-axis, and it is not symmetric with respect to the origin.